Okay, so we're going to just talk about that angle bisector idea again. It actually has a theorem. It's called the Triangle-Angle-Bisector Theorem. So if a ray bisects an angle of a triangle, so here's our triangle, here's our ray that is bisecting angle V, giving us two concurrent angles. What it does is it divides the opposite sides into two segments. So it divided the opposite side into two segments. Maybe I will highlight. Here's one of them. Here's the other one. Such that the ratio between the segments, right here, is the same as the ratio between the sides adjacent to each segment. So if you look at the proportion we're allowed to set up. So again, we have an angle that was bisected where it hits the opposite side, where that angle bisector hits the opposite side. It splits this side of your triangle into two segments. If you take one segment, UX, put it over the other segment, WX, that will be equal to the adjacent side. So the side next to this one is going to be UV. So UV over the side that's next to this one, which is WV. We put that over WV. Okay, let's put this into practice. That's kind of wordy up there. So example 5, let's use the Triangle-Angle-Bisector Theorem. What are the values of AD and DC? Okay, so what we notice is we have a triangle and we have these two congruent angles, which means this is an angle bisector. All right, your angle bisector splits the opposite side into two segments. So here's one segment, here's the other segment. So the angle bisector theorem says that if we take AD, one of those segments, and put it over the other segment, DC, so here's our angle bisector. It hit the opposite side, giving us two segments. So you put one over the other. That will be equal to, we're going to use the adjacent side. So here's side AD. Which side is adjacent to that? AB. So that's going to go on top, AB over. And then in our denominator we have DC. What's the adjacent side to DC? That is this side right here, CB. And now we are going to plug in what we can. So we can see that AD is x units long over DC. Well, they didn't tell us what DC was. We know the whole thing is 13. We know this part is x. So that means that DC must be 13 minus x. So the whole segment minus this x gets us 13 minus x. We're going to set that equal to, now we have to find AB. AB is 10. And CB, here's CB, is 16. What this does is this gives us an equation that we can solve for x. We can plug x back in to answer the question, finding the values of AD and DC. All right, so we will cross multiply. 16 times x is equal to the other cross product. Now that 10 times the 13 minus x, make sure we put that 13 minus x in parentheses. That will force us to do that distributing. So 16x equals 10 times 13, 130. 10 times a negative x is minus 10x. Let's get those x's to the same side. We're going to add 10x to both sides. So we have 26x equals 130. When you divide both sides by 26, you get x equal to 5. All right, so if we go back to our picture, we are trying to figure out what AD is. Well, AD is whatever we got for x. We got x is 5, so that means AD is 5. And then DC right here is 13 minus whatever x was, x was 5, so 13 minus 5 gives us 8. And there's AD and DC.